Welcome everyone who's here in person, people who are online. Today, for the IRC seminar, we've got Daniel Nüst from Dresden. So his background is in kind of geoinformatics, and he's an RSE at TU Dresden. But today he's talking about something that's a bit more cross-discipline and applies to all academic codes from the subject of reproducibility. Thank you very much.
Thank you, Jack, for the kind introduction, and thank you for having me. It's great to see some people online and in Cambridge as well. I'll try to keep an eye on the chat if there are any questions coming in, but otherwise I think we can take plenty of time at the end to discuss, and I'd really keen on learning on your thoughts about our projects that we call CODECHECK and Reproducible Agile. So the title for today is Code Execution During Peer Review with CODECHECK. And defined here at the bottom, the link. Let me also copy that and put it into the chat so that you can follow along at your own pace or revisit the slides later. So I just very briefly want to recap what I mean when I talk about open and transparent research. I would like to do this sort of from the other perspective. So let's remind ourselves what closed and irreproducible research means. This means that closed and irreproducible research cannot be fully understood or verified. It obstructs effective reuse and extension, and therefore it's not sustainable. It prevents usage in education contexts or also citizen science. And closed and irreproducible research effectively slows innovation through closeness and repetition, because we have to do things often all over again, which even though others have already succeeded in completing a task. So no talk about reproducible research is complete without Kleebout's claim, and I want to also mention this to sort of set the scene what I mean when I say reproducible research. An article about computational science in a scientific publication is not the scholarship itself, it's merely advertising of the scholarship. The actual scholarship is the complete software development environment and the complete set of instructions which generated the figures. And I hope the words here, software development environment, are a good connection for this topic and your interest as participants in the RSE series of talks at Cambridge. So I'd like to start this talk with some basics around reproducible research and how you, if you are a researcher or if you're working with computational research, can make your own work reproducible. I'm starting with that because that might be the most important thing that I can tell you from my experiences, how you can make your own work a bit more reproducible. And then we'll continue with the CODECHECK initiative and the Reproducible Agile initiative and go into more details. But for starters, I want to explore a bit the challenge that researchers face when they share their work, and that is that there is no really good set of instructions for sharing your work in an open and reproducible way. At some point this reminded me of this pretty old meme that's been around for quite a while that goes sort of gives instructions for how to draw an owl, and this is the first step. So you draw two circles, so for the body and the head of the owl, and as the next step is draw the rest of the owl. And that's to some extent also the current state in sharing your research, because we cannot give you a full set of instructions because often your research environment and your set of scripts or code and libraries that you use is so unique that there's no perfect set of instructions around. So to that extent, the one thing that I can tell you about how to make your own research more transparent and reproducible is that you should have a README, and in the end, everything else is just details. So in that README, it would be great if you show your willingness to help somebody else, but never stop holding back or start not publishing something because you think there might be a lack of documentation or something is not nicely formatted enough. But just put things out there and have a quick README that documents the steps for somebody else. And that is already a lot more than many researchers today do in their daily practice. And because it's really hard to document for someone else, I encourage you to not even try and to document for future you, document the main steps that you think you would need if you want to reproduce your own workflow, your own pipelines again in 10 years' time. And then you can document in more detail if somebody actually asks about your work. But one thing is not enough. So maybe with the experiences that we made, I also came up with 4 things on reproducible research. So besides having the README, we think that a great approach to improve reproducibility is that you have a colleague who runs your workflow before you submit your paper, before you publish your preprint. And because that means that somebody else looks at your instructions and checks them, and if they work for them on their machine, that's already a huge step forward. And of course, somebody has to do this, so you should yourself also practically reproduce papers. And in our experience, there's no better way to learning how to share your own work than trying to reproduce somebody else's work. And when we talk about scholarly communication or working in research, the call is, of course, the encouragement to publish your coding data. You should ask for coding data if you are active as a reviewer, and you should, of course, give credit to coding data that you use. That's sort of the things that we can do in the current academic settings, locally and internationally, to encourage people to be more open with their workflows. If you want to learn more about reproducible research, I recommend the Turing way. Unfortunately, we cannot make a quick show of hands, but maybe you can also raise your virtual hands if you've heard about the Turing way before. It's a great initiative that provides you, thanks Nick, and that provides you a great guidelines for working as an open researcher, open scholar. Okay, so let's shift over to reproducible research and peer review. So I like to say that reproducible research and peer review are cornerstones of science, of course. So sometimes say all research should be reproducible. But in my experience also, these topics or these aspects of research might sometimes look at each other a bit skeptical, and it's not really clear how these two can get along. So that's why we came up with, and that's why we came up with a solution. Another image of the current situation is that in your lab or in our labs, we have all the details, right? We have the data, the code, we have all the results, intermediate results. We might run specific models and have computational notebooks. But the thing that we share with the outside today is, even though, of course, the culture and the practice is shifting, but the vast majority of things that are shared still are papers as PDFs. And of course, this hampers, as I said before, reuse, transparency, and collaboration. So what we've created is an approach to have independent execution of computations that underlie research articles as part of peer review. And we call that CODECHECK. Who we are, I'll explain in the end. The principles of a CODECHECK are that CODECHECKers record, but they don't investigate or fix. We sometimes compare that to crime scene photographers. Like we're not solving a crime, but we're making sure that at one point in time, everything was there and everything sort of is captured and documented. But it's not the code checker's task. And so the code checker is the person who conducts the code check, obviously, to fix things. That's the task of the author. In our experience, also, we've learned that communication between the humans is key in making research reproducible and transparent. As I said before, it's really hard to document to a perfect extent and to imagine all the issues that other people might have with a workflow that you work with every day, or with a set of tools that you work with every day. So being able as a code checker to just contact the author of a paper and ask, yeah, so I have this issue, what was the problem? Or maybe can you help me fix it? And going back and forth, even in short intervals, it's much more effective than authors trying to come up with the perfect set of instructions. We think it's important that code checkers are given credit, as sort of in the same way as reviewers get credit. And we also say that workflows must be auditable. So it's not only saying it's the responsibility of the authors to fix issues, but they are in the position that to create or to share their work in a way that it actually can be code checked. And finally, we also added here to the principles that we say we want to be open by default, as open as possible. But we also say it's sort of transitional. If at some point a community or a journal decides that, or research, the academia as a whole decides that we are taking care of code and data as part of peer review, we are happy to just call it peer review again. But for now, we say it seems to be warranted that we don't only have peer review, but also we have, as part of peer review, we have code checks. So if you want to learn a bit more about the background, there's a video on our website, and also there's an F1000 paper that goes into much more detail about the ideas behind CODECHECK. So we've published over 60 certificates so far, where we reproduced work to an extent that we say a code checker took a workflow, ran it, there were no major errors, and the results look close enough to the ones that the original creators of a workflow shared, so that we award a certificate and maybe also give some feedback. I'll have some examples in a few minutes. So what I want to show here is that this figure from our paper is that we're not saying there's one right way to do a code check, but we want to show that all the different variants that you could do of executing code as part of a peer review and submission process of a scientific paper. So there are many different options that you can have, how important the check might be. So you could do it. And so also let me combine these, who does these checks. So maybe two extremes would be, you either have volunteers who do a post-publication code check of a paper that's just published in a journal, or you might have editorial staff who do a code check before something is sent out even to peer review. So you might say a journal says, this is so important for us that we are not handing it over to peer reviewers before we have not checked that so the basic mechanics of a paper are actually functional. And not only do we say peer review does not cover this at the moment, having a code check also gives us the freedom to separate the roles of scientific peer reviewer and a code checker, which means that we might be able to bring different expertises in. So I've done code checks for scientific disciplines and bioinformatics, imaging, that I have no clue what the science is about. But I am able, with my experience as a software developer, to sort of get things working, install the dependencies and call the right functions so that figures or data are created. But I'm not checking if the things make sense. sort of another image that I like to use is if you imagine that that an academic or a research pipeline or workflow is like a car. I'm checking that I can turn on the engine and that there are 4 wheels. And maybe if I move the steering wheel, the wheels turn, and maybe I can start driving. But I'm not checking how fast the car can go or what the speeds are, or the maximum speeds in a curve are, or whatever, how many people I can fit in. I don't care about these details, but I am making sure that it's a car. So in the future, if somebody else really wants to go deeper, with the code check, we sort of make sure that we capture all the things at one point in time that future researchers might be able to investigate in more detail. So we're setting a low bar, not only to make sure that we can actually pass it, and we're not spending hours and hours fixing computational workflows for papers who might maybe not even have very impactful scientific ideas in them. So that's a brief look at how a couple of these certificates look like. So this is actually one of the very first certificate that we published. We of course publish these with the DOI, either on Zenodo or on Open Science Framework. So here we have a little summary text and also a summary table of the output files that are generated. So ideally the author would tell us which are the files that a workflow generates, and these are then the ones that we look for and compare. And these certificates often have a little bit of text where we say these are the instructions, or this is the GitHub repository where we took the instructions from, and I went through steps 1 to 10 in the README, and these are the things that come out. And then we take screenshots or import figures to the document and share this certificate. So here you see an example of these code checker notes. So depending on who does the code check, I tend to be quite extensive here, sort of writing down as I go along. And this is also good, sort of writing these down, and then sometimes I send a draft to an author and go, yeah, this is where I'm stuck, and they know what I did, and they might point me to, yeah, well, in the very beginning, I'm sorry, I forgot to pin this specific version of a library, and that's why this didn't work for you. So I can sort of have to go back maybe a couple of steps, and then I can continue later. Here, even there was one code checker, Raniero Silva, who contributed a code check, who even sort of did some extra legwork, and in his report put the original and the reproduced figure side by side. And what you see here is that at the bottom, from the preprint, we have a figure that has a different aspect ratio and a different bit of text size than the one that he created at the bottom right. As a human, you can look at this and you can even notice, you see the colors match and the categories and the legend match, and the numbers might even match. For a computer to decide that this is actually the same output is really, really hard. Whereas for us humans, it might take you 5 seconds to say, yeah, this is close enough that you would say, I was able to reproduce this. So that's why we think a human in the loop or a human communication and the person doing these checks is much more beneficial than telling authors to provide sort of bitwise perfect reproducibility that a computer might check on. Right. So one instance or one implementation of CodeCheck is what we do at the Reproducible Agile initiative. So Reproducible Agile is a group of people that came together in the context of the Agile conference. That's a conference in the domain of geographic information science. The name is quite unfortunate. I think they start calling it Agile GI now. And Agile is the Association of Geographic Information Laboratories in Europe. So it's a group of labs that run an annual conference. So there we started in 2017 with the workshop on reproducibility. We wanted people to submit papers and to reproduce them. Nobody submitted any papers to the workshop. We didn't reproduce anything, but we realized that we think this is an issue, but the community does not seem to think that this is an issue. So we wanted to learn more. We are scientists, so we did a study on the reproducibility of agile papers and published that. And we found out that they are basically not reproducible at all. Even just 2 years ago, the papers that were published, they might have a link to some data set published on a private website, but that the link is broken now, etc. So while we set out and said, let's try to reproduce papers, we ended up documenting for what reasons papers are not reproducible. So in 2019, we were lucky enough to get some support from the Agile Council, which is sort of the governing body of the Agile Conference. And we came together and we developed the guidelines for reproducible publications for geographic information science, or for this conference. And we sort of put these guidelines out there and pointed authors to them. And in the years after, we were slowly taking more and more advanced steps. In 2020, we started doing reproducibility reviews, and we've been doing that ever since. And with the difference that in 2022, for the first time, following the reproducible paper guidelines actually became mandatory. So how do these guidelines look? The idea here is that we want to enforce transparency, but we're not sort of enforcing people to change the way they work. So the only actual hard demand is on the first page. And this says, following short papers submitted to the Agile Conference have to include a data and software availability section, which documents data, software, and computational infrastructure to support reproduction, or mentions reasons for not publishing them. So the idea is we want to promote highly reproducible work, but we're not excluding anyone for not wanting to or not being able to share their work. So sometimes there are good reasons. So you might work with a proprietary data set. A case we recently had at Agile was that somebody worked with a free floating car data set from a large international navigational company. And of course, they don't want to give this data away. And that's fine. So we just say, please document. And of course, we all don't like data and software available upon request. But if somebody feels like that's still appropriate to write in 2023, they can do that. And we ask them to do that in this specific section. These guidelines provide a couple of checklists for authors to make sure that they share their work in a most reproducible way possible. But they also have guidelines for reviewers. So what steps do you take as a reproducibility reviewer, and also for regular reviewers, because there we sort of want to make clear that what we as the reproducibility people expect regular reviewers to do, and also what we don't expect them to do. So the review process is Agile works like this. We review full papers only after they have been accepted or rejected. The reason here is, again, we don't want to exclude papers early on. We want to promote the ones that are reproducible. And also the review at Agile is double blind. So no, double blind is not the right thing to say anymore. We say that is fully anonymous, so authors don't know reviewers and vice versa. And that, of course, when we do it after, we have no limitations anymore. We can talk directly to the authors, and we just say, congratulations for your paper being accepted, and I'm now your codechecker, and can you please help me to run your workflow? So doing it at this point in the review pipeline or in the review process allows us to communicate with the authors freely. But this is also, it's a community conference and completely organized by volunteers. So we also don't want to put efforts into papers that might not even be accepted in the end. And then when we publish our reproducibility reports, which is the same as a CODECHECK certificate, it's just because these two initiatives sort of developed in parallel a little bit, and we've never gotten around to agree on a branding or naming of things. We have these nice little blue and yellow badges on the landing page by the publisher, and also on the cover page of each article. So we make sure that there are some references going from the article to the reproducibility report as well. And looking back over the past years, we've after the first time where things were not mandatory, we just had 27% of papers successfully reproduced, but now the numbers are up, and over the last couple of years they sort of moved around 70% of all submissions, or sort of all accepted papers being successfully reproduced. And of course the numbers here vary highly, partly due to the conference reacting and different kind of settings for the conference due to the COVID pandemic. But I think I'm pretty happy with these numbers, that we can almost 3/4 of all papers have been successfully reproduced. And of the others, I would say that's sort of an even split between this is a conceptual paper, so there's nothing to reproduce, and maybe then each year there's a couple of papers where authors don't want to or cannot share their material. Right, so this I'll jump over this for the sake of time. Just want to mention that these are how the reproducibility reports look like, and because we publish them on OSF or Zenodo, these things sort of automatically end up in your OCR profile, so your online presence as a person in academia, and you can, I think, rightly put this on your academic CV. I'll just leave these uncommented. A few more impressions on how such a CODECHECK certificate or reproducibility review can look like. Right. So to wrap up the Agile topic, how to put your community on a path towards more reproducibility in 5 hard steps. So we started with a team of enthusiasts with our workshop, and said this cannot be it. We have to change something. And we did the assessment of the state of reproducibility. It was bad, which helped us to convince the institution behind the conference to say, okay, let's do something about that. And we focused on positive encouragement, right? So we're not saying because something is not reproduced, doesn't mean it's bad science. There might be very good reasons for it, but we still want to shine a light on the ones that are reproducible. And then we just were lucky enough to have a group of people that could keep at it for a while. Also, I think that this Agile conference it's a community conference, about 200 people each year, and that's sort of a size that where if you just go there and you want to do something, you can actually change something. But I would argue, and this now leads over more to the things that I hope you take home with you today, is that CODECHECK is transferable to your discipline and your community. So we have these ideas that there is a human-centered process, we focus on communication, and we do have a supportive framework, sort of tools and infrastructure. But this all is something that you could also start to establish. And I'm not sure, maybe we can do this very brief survey of the room again. Who of you would say that they are an RSE in more than they are a researcher? Maybe somebody can just shout how many hands there are. So the people are raising their hands in person. Yeah, 5 out of Is there an even split?
Students.
16.
Yeah, okay, good. So I think that by now it probably became clear that having RSE skills is very essential to be an effective code checker, and thereby RSE skills are crucial for academic peer review today, where we have probably more papers than not relying on some kind of data analysis. So we say this human-centered process is able to handle the huge variety of workflows that we have much better than some kind of automation that we have. So this is repeating some of the points I made before. The author is responsible to provide good material, but this can be a collaborative process. So sometimes as a code checker, if it's an easy fix, I don't know, a path is fixed, but I can turn it into a relative path in 20 seconds. I'm of course doing that instead of writing an email to the author. Right? And then sometimes also the authors always welcome these feedbacks or changes. And then I'm also happy as a code checker because I did something useful that day. Right. And we're also doing sticking with the main concept of peer review in the sense that the code checker stops when they are confident enough that all parts are provided and they write the certificate. Same as a peer reviewer. The peer reviewer writes their report and says, well, this makes sense to me and it's good enough to publish. And we trust this person just as we to build trust in the whole process. Right, so the communicative focus on reproducibility, when I have the time, I'll just see what things I haven't mentioned before. Another advantage that I did not mention yet is that, of course, as you might be aware of, computational notebooks, Jupyter notebooks are great for communicating science, for conducting computational research in a reproducible way. But we're pointing people to these resources, and yeah, you should do it this way, but we're not saying you have to do it this way. We're not saying you have to provide a Docker container that I can run with this command, and then we have a hash, a script that calculates the hashes of the outputs, and only if everything is green, then you are reproducible. We don't want to play sort of catch with innovation and technology, and we don't want to impede on researcher freedom and sort of limit that. But say if we talk about it, we can figure it out. Right, and that is also makes it, in our experience, a positive learning experience for everybody involved, be they the code checker or the author. And of course, tools and infrastructure to do these things exists. They can especially make code checking easier or faster. So things like notebooks, I mentioned putting notebooks in a binder-ready repository. If you don't know what that is, ask me later. And sort of using open methods approaches certainly makes code checking easier. And of course, you can always, as a technology person on RSE, you're eager, and I'm talking myself as well. I am eager to put more tools and more technology and more automation behind these things. But the more I do that, it always has encouraged me in saying we need a human in the loop for these kind of things. So maybe afterwards in the discussion, we can chat about, or you can reach out later if you have a candidate in mind, where you say, well, this is actually a journal that I know well, or this is a workshop series that I know well, that I think could be a valid candidate for trying out a code checking procedure. And we'd be very happy to talk to you about that. So what can you do today? What can you do today? So it was a bit quick. You can learn how to code check, and it's not that hard. When you learn that, it's best to do that by joining or starting a local community or a journal-based community or a conference-based community of code checkers. and effectively shift practice one paper at a time. So that in the end, we might just talk about peer review again. And peer review would mean that, yes, people actually look at data and code. And who will look into data and code? If I haven't made it clear before, I think RSEs can play a crucial role in improving the reproducibility of computational workflows and improving the strength and the usefulness of peer review, because we also take a look at code and data. So I'll skip over this for the sake of time, but you might be aware, if you're an RSE, of the nice phrase "better software, better research," coined by UK RSE some years ago as a campaign. And I like to extend this saying to better checking of software by RSEs, and software meaning all software that is related to some piece of research, improves peer review to foster better research. Right, so what else can you do instead of just becoming a code checker? You can, of course, make your own work reproducible. And as I said before, if you're ever in a role of somebody who reviews for somebody else, be a bit more demanding, but also be helpful and try to make things work. And so we start a discourse not only in conversations with authors, but maybe also in conversations with reviewers and editors. If you write a paper and you realize that the reviewer has not checked your code and data, why not point them to it again? These are some resources if you want to get into the topic of reproducible research and open science. So this is just a few links that I might revisit in the discussion. To wrap things up, I want to spend one more minute on why you would do this. Why would you become active as a code checker? Well, I think it's a very great experience. You're doing something useful and good. If you give feedback to other people's work, and if you actually reproduce something, you're increasing the quality and the reusability of the science that is shared. And your feedback will always be welcomed by the original authors. And this really, in our experience, and we don't have the hard numbers for that yet, but we're working on those numbers, that these code-checking interactions between authors and reviewers really can shift can shift how people work, a community works, and also how they can really spread better practices around academic or scholarly communication in the sense of what we share and how we share it. Right. And these are more trying to practical things that also come out of it. So you will get to know all the package managers that exist, because researchers choose their tools, sometimes a bit randomly, and that can be useful in your work as a developer. And it really sort of hones your skills as well. And sometimes I do a code check and I feel like, yeah, this might actually be a tool that might be useful for my own work at some point, and I've already made the first steps with it. So that's also really a fun and educational experience. Okay, so we say code checking is a craft, and you learn crafts by doing. So from being the little kid that learns how to use a hammer to become the expert craftsman, that takes time and practice. And I don't think there is another way around that. Certainly not rules or documentations, but yeah, there's no way around doing things. And in all the process, I invite you to be kind to each other and help each other. And that's, I think, how we can make more work more reproducible in a observable speed and not just wait for all reviewers not for all young academics today who maybe have these views and do share these ideas and principles to become the old reviewers of the future. If you want to get in touch, you can always chat to me. I forgot to put the social media links in here, but they are on the CODECHECK website at the bottom. If you follow us, and who is us? That's not just me, but the co-PI of CODECHECK is Stephen Eglin, who is a professor at Cambridge and in the maths department. He would certainly be very interested if you stop by and just put your head in and ask a question about CODECHECK. And he knows that I am giving this talk today. Unfortunately, you couldn't join. But yeah, as I said, we would look very much forward to your questions and comments right now or in the upcoming weeks. Thank you all for your attention.
Thank you, Daniel. That was really, really good. If there's anyone with questions online, they can either drop them in the chat or stick their hand up and I'll get to them. I know we have a few people who are keen on reproducibility in the audience. And if there's any questions in here, so one that I had was, suppose I've got collaborators or I've been working on something and it's a paper published in a journal that doesn't particularly promote reproducibility. Is there something sort of, after that's been accepted for peer review, is it possible to come to you guys and apply for that to be code checked?
Yes. So a couple of words maybe about where the project is now. So we are looking through these talks we're giving and through starting conversations with people. We are looking for journals or conferences who are interested in exploring this. We have experiences in running a CODECHECK process, but we are not the ones who run the journals. So we would like to collaborate with people, share our experiences, also contribute our code-checking time, and help people to establish these kinds of workflows. Sorry, can you repeat your question? I can't tell.
You said you'd partnered with some journals to sort of award these badges, but suppose that I've got some kind of software.
Okay, yeah. If you submit that to a journal where that doesn't happen yet. So what we've done in the past a few times is that we just sort of what we then call a community CODECHECK, where we basically do the CODECHECK for the preprint, or we just publish the certificate and you link to the certificate from your submission. Right? I mean, no journal today will reject your paper because bits and pieces are already on GitHub today. Nobody is that's sort of this prior unpublished work. I think is pretty ridiculous today with code and data based workflows. So we would do that, and we've done that in the past, and we're happy to do that. But ideally, that leads then to a conversation with the handling editor, and we've also had these conversations, but they are always pretty tricky because it takes a long time to shift these well-honed practices and habits that people have. So we would do that if it leads into a conversation with editors or publishers, so that we can talk how to make things more long term.
So I've got one from Nick Taylor, who says a lot of software-based projects where they work are very sort of computation intensive, using HPC and using molecular dynamics. So how would you go about performing code check on something like that if you don't have access to a HPC cluster or the specific cluster on which it was run?
Yeah. So I broadly two solutions. One solution is find somebody who has access to an HPC cluster and ask them to do the code check. But of course, there is, it might be a waste of computational time and resources as well. So if it's not the authors cluster, what we've done once is for one workflow, we've moved things to another cluster. So Stephen could talk to you about that, how we did that. It was actually, I think, a paper that by Neil Ferguson in the context of the COVID pandemic. So there we said this is actually quite important, and we go through these steps, even if it takes a lot of resources. But a more practical approach that we would take is when I start a CODECHECK and I go through the instructions, normally it takes me like 15 minutes until I hit a installation problem and I write back to the author. And then it takes me another 15 minutes maybe to run the code, and then I start it. And then I see some progress bar, and after 1 hour, and I don't see sort of a number that is small and goes down, I'll just abort and ask the author, this doesn't work for me. I cannot wait sort of for days to complete this. I might have a good laptop or work, good computer, but we don't want to wait for days for this to finish. We would ask you to provide maybe a data subset or a sample and a reduced configuration for the computations, and provide the outputs for that as well. So maybe depends on you said your molecular dynamics. I don't really know what that means, but you could have a coarser result or something like that. In machine learning, you could just go through fewer iterations of learning, and then the model is of course really bad, but we can still compare your outputs with our outputs, and make it more manageable. So we would still make sure that the code that you provided works. And we would still sort of make sure maybe that the data that you provided is actually there. But we postpone the actual detailed reproduction until a point in time where somebody else maybe wants to build on your work and wants to extend on your project and data, so they can then go into more details. Hope that makes sense.
Yeah, and I think, I don't think it was SC, but there was a supercomputing conference that similarly awarded badges to papers for reproducibility. But I think they had an arrangement whereby the conference provider sort of put aside so many hours for reviewers to run codes that were submitted.
Mm-hmm.
So I've got, there's another question from Marion here.
Yeah.
Who's quite ReproHack initiative. She said she can see it's listed as a CODECHECK partner, but wondered if you know more about how they collaborate, or whether it's just that you sort of acknowledge that both are doing good work in the area.
Right. So as we've talked with ReproHack or with the ReproHack team in the past, and we would like to collaborate more with each other. But similar to ReproHack, CODECHECK is a sort of a side project where we're still struggling to sort of get proper funding to do things in more detail. What we would like to do together with ReproHack is, if you complete a ReproHack, you basically also know how to do a CODECHECK. And if you, we've also done recently a CODECHECK workshop at TU Delft in the Netherlands, and it was very similar to what you would do at a ReproHack. There is a bit of organizational difference and how the papers end up being checked or being ReproHacked. But in that sense, the things are pretty close. Of course, the difference is that we try to shift practice in the context of peer review, which is not one of the primary goals of ReproHack. So in the past, we wanted to collaborate on sort of instructions for codecheckers and ReproHackers and provide helpful documentation there. But as I mentioned a few times, it's pretty hard to provide a good set of instructions. I think this sort of that always kept us a bit from going further with that task. And us more, so it's also a practical decision to say, let's not document too much, but take more of a crafts approach where we would rather take a mentorship approach to say, I train other people to become code checkers, and then these people can also do a few checks and then become trainers as well. So yeah, we do acknowledge each other's existence, but it's a bit more than that. If we ever get money, we would certainly be very happy to also support repro hacks more than we're doing now.
In that case, thank you very much for coming to talk to us today. And hopefully that was very useful for.
Thank you.